Hey guys, we are going to do Chapter 1, Section 2 today using segments and congruence. So for a warm-up here, draw this figure here on the right, do your best, copy and answer each statement. So take a few minutes and do this warm-up. Alright, so 3 points that are collinear, so along the same line. That would be S, P, and T. M is not a point, M is the name of that line. So this is and T. Name 4 points that are coplanar. So they all share and are on the same plane. This plane R here has S, P, and T from the line and also V. S, P, T, and V. Name 2 points that are non-collinear. So they are not shown right now on the same line. You could do V and Q, and there are a bunch of different options there. A few other things that we learned in section 1.1 that we did not get to finish the other day is talking about line segments, rays, opposite rays. So let's look here. Name 2 rays. There are a bunch here, so just name 2 of them. Remember, a ray starts at a point and goes through another point and continues on for forever. So there are a lot of different rays here. I'll just pick S as my endpoint, for example. So ray SV, make sure you draw your symbol here. So ray SV would be this one. If you wanted to do another one with S as the endpoint, you could do ray ST. And there are a bunch of different ones. Name 2 segments that have V as an endpoint. 2 segments, line segments. So V is right here, and shown in the figure, a line segment, VS would work. And what would be another one? Line segment. If you said VQ, you are correct. The line segment VQ would be this one here. Name 2 opposite rays. So opposite rays have the same endpoint, but they are going in opposite directions. In this case, we have to use S because S is collinear with 2 other points right now. There are no other points along these 2 rays and lines here in order to get opposite rays. So we're going to use S, we're going to use SV, like we did earlier, and SQ would be its opposite ray. Here is SV, and here is SQ. Alright, in geometry we are going to have postulates and axioms and definitions and theorems. All of these are very important, so we should be writing these down, and they they will need to be memorized and utilized in whatever form we need them to be. So postulate and axiom, write these down here. Alright, so the ruler postulate. The points on a line can be matched with real numbers. The number that corresponds to a point is the blank of the point. That is coordinate. So if you have a point at the number 5 on the number line, that would be its coordinate. The distance between A and B, we label that as AB, measures the length between A and B. And in a second we are going to see what that is talking about. So take a minute and write down this ruler postulate here. Alright, segment addition postulate. Please write this down. Visually here, if B is between A and C, between, it would mean that it is on the line segment AC, And this postulate means exactly what it sounds like, segment addition. If B is between A and C, then AB plus BC equals AC. So that means you can add the distance from A to B and B to C and say that that distance equals AC. All right, determining the length of each segment in red here. Let's look at the first one, the top one. Starting at 0 and going past 3, and each of these tick marks, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this here, the length of the segment is approximately and 2/10, because from 3 to 4 it is broken up into 10 tick marks, and this one looks like it's about going to the second one. Simplifying this would be 3. What number goes into both 2 and 10? That's 2. So 2 divided by 2 is 1. 10 divided by 2 is 5. So that distance of that segment is approximately 3 1/5 centimeter. Go ahead and take a minute of determining the length of this segment on the bottom right here. This one looks like it is going about 3 tick marks past the whole number 1. So this would be 1 3/10. Simplified that fraction. So your final answer is 1 3/10 centimeters. We are going to use what we know about the segment addition postulate, meaning if a point is between two other points, then the sum of each individual segment equals the entire thing. And we're going to use that to help us find the length of GH. So the first one, by the postulate, it would say FG plus GH equals FH, the entire thing. We know, given here, FG is 27. We're looking for GH, and FH is 40. Subtracting 27 on both sides. That means the distance, the length of GH is 13. Go ahead and use that as a guide to help you with the problem on the right. Using the left-hand side as a guide, make sure that you are writing this equation here first as your guide. That is from the segment addition postulate, and then you fill in the information given in your figure. So FG is 15, FH is 22, solving that for GH is 7. Alright, so plotting points on the coordinate plane. Remember that the coordinate plane goes from x, y are our points. This is our x-axis. This is our y-axis. You move left and right first, and then up and down. Positive numbers on the right, negative numbers on the left, positive numbers up top, negative numbers on the bottom. So we are going to plot these points first. So point J is at -3, 8. So start at 0, 0, the origin, and go -3, so to the left 3 and up 8. Right here is J, make sure you label it. K, 2, 8. 2 to the right and 8 up. So that is K. Take a minute and locate and graph both J and K like I just did there for you. And also plot the coordinates of L and M. Alright, that is the coordinates of L and M graphed there. Now let's take a look. Are J, K, and LM, are they congruent? This should say congruent. Well, let's take a look. J and K right here. JK, that is 1, 2, 3, 4, 5 units away from each other. So the JK distance here, JK's length is 5. How about LM? 1, 2, 3, 4, 5. So yes, the answer is yes. So JK and LM are congruent. The symbol for congruent is an equal sign with this squiggle on top. All right. Go ahead and take a minute, and you are doing the same thing here for JK and LM, and this should say are JK and LM congruent. So go ahead and take a minute, draw a graph, and plot JK, L, and M, and decide if line segment JK's length is congruent to line segment LM. Alright, this is what the coordinates of JK, L, and M are, and then I drew in the line segments. So JK has a distance of 6, 1, 2, 3, 4, 5, 6, and LM has a length of 3. So they are not congruent. So the way you would say that is line segment JK, not congruent, so you draw a slash through line segment LM. If you were asked the length, JK would equal 6, LM equals 3. But when you were talking about congruence, notice that I put line segment JK and line segment LM. So make sure that you add that in there. Alright, last slide for today. Point S is between R and T on line segment RT. Use the given information to write an equation in terms of X. Solve the equation, then find RS and ST. So S is between R and T. Take a minute and try to set up an equation based on the segment addition postulate. If you wrote this, you are correct. Now we are going to substitute in what each of these 3 line segments are equal to for their variable expressions. So RS is 2x minus 8, and fill in the rest. This is what your equation should look like to write your equation in terms of X. And now we are going to solve our equation for X. So, combining like terms, x plus 5x, negative 8 minus 11, negative 19, equals 51. Add 19 to both sides. 70 equals 7x. Divide both sides by 7. X equals 10. X is just part of our equation, but that doesn't give us any information about what the length of RS and ST are until we plug back in 10 for X. So go ahead and take a minute and plug in X, 10 in for X in both RS and ST equations to get those lengths. Over here on the left in red is what the lengths of RS and ST are. RS equals 12 by plugging in 10. 2 times 10 is 20, minus 8 is 12. And then ST, plugging in 10 for X, 5 times 10 is 50, minus 11 is 39. A quick check that you could do using the segment addition postulate. Add your 2 values up and make sure that they equal the entire thing. So 12 plus 39 is in fact 51. Thanks so much, guys. Let me know if you have any questions, and I will see you next class.